So welcome to our joint webinar together with Platform9 and the DoK community on the subject, can data on Kubernetes become a declarative resource? Today we have Bart Farrell from the Data on Kubernetes Foundation. He's the DoK community manager. Chris Johns, lead product at Platform9, one of our favorite partners. Michael Greenberg, our head of product. And Uwe Zeidenberg, our DevOps lead. And today we're going to talk about if data can actually become a declarative resource. So what is declarative data, first of all? So it's basically data that is mounted on declarative agile infrastructure that can be mounted anywhere. It's supported cloud-independent storage, which means that it can be placed and be available on whatever public cloud we would like it. And it's globally available upon demand, meaning that it comes with the ability to either replicate itself or mirror itself across distances. And finally, it shares the same declarative user experience as the Stateful Kubernetes deployment that we all came to love. And Bart from the DoK Foundation, they actually did a big survey about it, about what are the challenges that are stopping the adoption of Kubernetes when it comes to data and in stateful sets in general. Bart, can you explain us a little bit about that?
Absolutely. First of all, very nice to be here. Thanks a lot for having me. As Roy just mentioned, last year as a community, we interviewed over 500 organizations to see how they saw the challenges and opportunities of running stateful workloads on Kubernetes. And as you can see right here, the results, obviously one of the primary ones is the lack of integration with existing tools. How can we sort of shoehorn these things in to get the right fit? Matched up with that is the lack of interoperability, not having that operational flexibility. Also, when we talk about things like portability, that being a particular challenge. Then also vendors not really being able to meet the needs that end users are having. So finding that to be challenging, that things very much have to be custom made. In general, a lack of standardization when it comes to tackling this problem. Then we get further down the list as well. Obviously, you'll see talent. It's no secret that every organization seems to be hiring, the challenge of finding the right people, extracting the insights that we see in this slide. When we talk about skilled talent, DBRE is still as a growing ecosystem, as is SRE. Getting cloud native data engineers, folks that are making the transition from DBA to SRE, is tough. It's challenging. So getting organizations up to speed is one of the reasons why our community started in 2020, so that there would be a common meeting point for people to exchange ideas and best practices. Then touching once again on the point of interoperability, the fact of vendor lock-in, what Roy mentioned as well too, that there isn't that flexibility and feeling that you have to be very much attached to one public cloud vendor. So that being a challenge as well. You can go to the next slide. So as a conclusion, with both of these being mentioned, is that there is this lack of standardization, which is once again why the community got started. We've done 123 live streams. We're working on our third KubeCon. Our last live stream was actually with Statehub, which was a lot of fun. I highly recommend checking it out. First for the content, but then also for the costumes that we were wearing, but that's another story. But anyway, this is just a nice rundown to get a sort of foundation for the stuff that we're going to be seeing later in the presentation.
So, Uwe, what needs to happen to give stateful workload the same experience as stateless? Your opinion as our DevOps engineer.
That's a good question. I think first, to answer that, I think we need to answer what is this stateless experience that we have been talking about. So I think it's has two main parts. One being stateless applications are declarative, right? So what means that when you deploy a stateless application, all you have to do is name the container that you want to run. And as long as your cluster has access to the Docker or container registry where this container is hosted in or registered in, you're sure that no matter where your Kubernetes cluster can run this thing. And the other part is once the Kubernetes cluster got access to this resource, this container, and run it, if something happens to the infrastructure, the physical infrastructure that is currently running this app, it can always move the application from one node, from one physical infrastructure to another. So these are the two things that we need to bring into stateful applications. We need to consume data as code, regardless its physical location or the architecture it runs on. We need to make it available as in declarative and declarative resource that will be available for our application no matter where they're running. Can you go to the next slide, please? And this is why we partner with Platform9. Together with Platform9, we provide a complete solution for stateful applications and make them easy as stateless and as easy and joyful as stateless application. Platform9 takes care of all the application layer, meaning they can deploy your Kubernetes application on any cloud provider, on any infrastructure, whether it's on-prem, AWS, Azure, GCP, no matter. And together with Statehub, we provide Kubernetes native storage that can be accessed from anywhere. And so you can deploy your applications, whether they're stateless and stateful, obviously a full stack. Any application has both stateless components and stateful application and stateful parts. So you'll need these two solutions. And so together with these two solutions, you can just move them around with a single control plane, move them from one point to another without having to worry about infrastructure or cloud specific skills. Next, Rudy. Could you move to the next slide, please? We make it easier. Basically, these two solutions together make it easier from the designing and architecturing of your application, because you don't need to overthink about a single provider, or what are the features that are coming with this vendor, or am I going to do this or that in the future if I want to, because you're obviously going to be able to move your application anywhere at any point. So these considerations are much less important to begin with. As for day one, our solutions are effortless to deploy. Both of these solutions come with the maximum automation. Both our products are made to be as Kubernetes native as possible. So you have the same experience as you're used to when using these. And as for day two and maintenance, also we bring a lot of the things that you have to worry about, like disaster recovery, copy management, and all these things. We're bringing in into our tools, into our services, so you won't have to worry about them later. That's it for me.
Okay, thanks a lot, Tori. Michael, the product manager, is going to present the demo.
Together with Platform9, we can get a sort of, let's call it, holistic experience with stateful applications in case of a disaster or any kind of business reason that you might have to move your application from one place to another. Here's an example of a e-commerce website, right? So we have a page with products, and we can also see on this page where it's running. Now, we have a few Platform9 clusters. For this demo, we're using one that's on AWS US West 1 and in Azure East US 2. So these are two Kubernetes clusters, and we're going to move a stateful application with two databases between them, along with all of their data in real time. And So to tie this all together, we set up a Cloudflare load balancer, and we can see that the application is currently running only on one of the clusters, only on one target. So this is why you can see that it's degraded, because there's only one cluster currently running the databases and the store application itself. Now, going back to the store application, we have the hidden back office orders page, right, where you can see right now that the application is running on AWS on the East Coast region. What I'm going to do is I'm going to fire up the orders simulator that's going to simulate orders coming in from the world, right? So we have constantly orders being generated, coming in, and the page is updated in real time from the database. Now, if we'll take a deeper look at the infrastructure, we'll see the store pod, the application itself, and the two databases. One is for the product database, and the other one holds the orders. Now, if we look at what did we actually do to make the databases transportable, movable with all of their data from one place to another, you'll see that there's no specific configuration done to any of it. So basically, we have a YAML file that describes both of the databases with clear text passwords. Obviously, don't do that. And we have a volume claim template that says that we're going to need 10 gigs, and the volume is going to be called DB data for Mongo and for MySQL. And so we see these persistent volume claims, right? And what we did with Statehub is really to tie it into the talk, to make them declarative. These are the persistent volume claims that are going to be visible from any cluster of yours that is registered with the Statehub system, as long as it points to the Statehub, the specific Statehub storage class, which is tied to what we call a state. A state is a collection of your volumes and a definition of where they are. Think of it as a registry for persistent volumes that's running on the cloud in a specific central place, although it's available locally to all of your databases. Now, it has two volumes. It's available at those two locations, as we can see. And that means that all clusters in these locations can access the data as if the data was local to them. And the name of the persistent volume claims is the actual name of the volume. So you just need to point any cluster of yours in the world to a volume on this specific storage class with this specific storage class, and it will point to the exact same data at any time. So exactly like you would do with a container image, right? It doesn't matter where you run your container, you point your Kubernetes cluster to a container image, and it will start running. Now, what we're going to do is, while we're running the order simulator to simulate activity from users, what's going to happen is we're going to run this script that looks scary for a second, but like 95% of it is just formatting. And this script is going to switch our operation from the East Coast to West Coast, from AWS to Azure, and it's going to do 5 things. It's going to shut down the store to simulate a failure, shut down the databases, although in case of a real failure, nobody's going to shut it down. But this is we're doing for the sake to make it easier. And then start the database on the other cluster and start the store on the other cluster. That's pretty much it. And in between, we're going to run a Statehub command that will switch ownership of the data from one cluster to another. We can see that the data is visible to both of these clusters. We're going to take the data ownership from one cluster move it to the other cluster, and that's pretty much going to facilitate the failover operation, right? So this is, consider this like kind of a fire drill of moving the operation from one location to another. So we see the orders, they continue to come in. We've shut down the store pod, the store application. Now our orders will start failing. We're shutting down the databases, and we've switched ownership to the other cluster, switched the ownership of the data to the other cluster, and applied the same, absolutely the same YAML file, because our data is declarative, right? The volumes are declarative. That means that they are the same wherever you are applying the configuration on. And once the databases will come up, the store application will come up, and then the load balancer will realize that the application is up and running on the Azure location, and operations will resume, and we'll see orders continue to come in. And more importantly, we'll see that no orders were lost. So we're taking tens of gigabytes in this case. It can scale up to hundreds or thousands or terabytes, and the store should, yeah, orders are coming in. And we're moving the entire application, the entire operation of the company with all of its data from one place to another place, and we didn't need to configure in a different way. We didn't need to point the Kubernetes cluster to specific storage that's available. This one has GP2, GP3 EBS, and the other one has Azure Disk. So that's pretty much that. And we see, by the way, that the store is currently running on Azure. Roy?
Okay, thanks a lot, Michael. Chris, how do you think this will work when it comes to your clients and the challenges that they have in Platform9 dealing with stateful workloads?
That's a good question. It's interesting seeing the survey results at the top of the session. 100% that resonates with basically everyone we interact with Platform9. We have a free platform, people jump on, try things out, get on Slack, ask questions. We've been running that since March 2020, and I can attest that nearly all users that come in have questions about storage. How's it working? Why isn't it there? What do I need to do? And that isn't even like getting up to that level where they're asking about, how do I do this with a real world application? And how do I then keep it available? Let's say if Azure or AWS does have an outage, right? There's a lot of businesses that learned the end of last year that running in just one region was a big problem. And then you have this Platform9 customers, for example, that also run, in AWS with EC2 machines that are using volume mounts and their availability zone locked.
Yeah.
So to me, it's a pervasive problem. I think the survey really calls out that people have no idea how to even begin solving this. How do we see our users and customers solving it? They don't have a solution to this, right? Some businesses might just say, hey, I'm just going to go and consume yet another public cloud service and try to just outsource the complete database problem. That's not necessarily going to give you flexibility. It might give you some mono cloud, it's like single cloud availability, but it's still relying on another service. And if that region's got an outage, you've got a problem. Or if RDS is having a problem that's pervasive, you still have a problem. I don't think anyone's really solved this. Specifically, how would I see our customers using this? It's getting out of the trap where people are dependent on what's available in an availability zone to their EC2 instances and stepping away from that, as well as moving directly into recoverability. So giving themselves the ability to say, hey, we're going to run in this region anywhere in the world. And if there is a problem, we're not going to wait to see how long this goes on for. We're just going to immediately fail that over another region, and off we go. That's the biggest strength that I've seen here. This is a great demonstration of doing it across multi-cloud, so AWS and Azure. I don't see this being any different from an AWS to AWS perspective, right? There's still things that need to be protected, still things that need to be replicated. And I think it's significantly easier and potentially safer than trying to stand up your entire environment and then start backing up into all of the individual applications with their own type of tooling. So if it's running Mongo, using a Mongo backup, having Mongo running in your other cluster and replicating it over, that's going to drive up costs. When really what you're looking at doing is making sure that you've got the entire stack well-formed and declarative. So when the data's there and Mongo comes up, it just continues operating like it was on the other cluster.
Cool.
Yeah.
Cool. Thanks a lot, Chris. Michael, can you walk us through the architecture a little bit of our joint solution?
There are two main components, right? There's the application stuff, the Kubernetes clusters that are provisioned and managed by Platform9 in the fictional customers' environments or cloud accounts. And the data component is handled completely by Statehub. So we have the control plane for the application, the knowledge of what's running where at any given moment on Platform9, and the ability to basically have the data waiting for you wherever you're going to start your application, provided by Statehub. Every bit that's being written to disk by Mongo or MySQL or any other data application, but in this case, those two, is getting replicated in real time to all of your other locations. So when the time comes to bring up your application there, you can just switch ownership and you'll see the application coming up on the other side with all of its data and without any sort of gaps in the data, nothing missing. You can resume your entire operation somewhere else with all of your data immediately. Yeah, and to tie it all together, or to, let's say, we haven't mentioned it explicitly yet. Statehub is a service, right? So the way you would consume EBS or Azure Disk or a GCP disk is pretty much the same you would consume Statehub from a Kubernetes standpoint. What we give you is, upon a persistent volume claim creation from your Kubernetes cluster, we would provision volumes that are replicated between all of your locations, right? So the way you work with Statehub is that you would register your clusters, and then they connect to our data fabric. And we have presence in all of the public cloud regions, currently AWS, Azure, and GCP coming very soon. And we take care completely of all the networking and data operations that come into play when you need to replicate the data. So the data is being replicated automatically between all of your locations. You don't need to solve a networking problem when you have a replication problem that you're trying to solve, basically. Next slide.
That's it.
That's it. Great.
Basically, just to sum up what Michael and everybody basically said, the problem with stateful Kubernetes is just really complicated. It's really complicated, and what we usually do is we go to whoever provide us a storage or whoever provide us the infrastructure, and we just stay put. We make decisions and we think a little bit ahead of trying to enjoy more cloud services from more places, to think about fault tolerance and those basic IT 101 that we learned a long time ago, and use services that don't close doors, but actually open doors towards us. We can reduce the level of complexity to consuming two very simple managed services that can assure that not just I don't have to deploy a lot, or to that I don't have to maintain environments, I don't have to think about to learn about storage and replication and all of these horrible things that we went to the cloud to enjoy. And that's about it. Anybody else have anything to say before we stop?
I'll say, Roy, you touched on a pretty important part right there at the end. Setting up a cluster, deploying your app, and then not really worrying about the storage, replication, or all those 101 things. There's a lot of customers that we've been talking to recently that have been using Kubernetes since 2016, 2017, have gone through the painful journey and now running at scale in the public cloud, right? These are people that have tens of clusters, 50s, 60s, 70s, or even people that have a lower number of clusters but have thousands of nodes. And they're worried about what one customer told us is the blast radius. When something happens in one of those clusters, it takes out everything, or it has the potential to take out everything. So people with these large singular clusters are trying to compose them down into smaller pieces. And people that have the smaller clusters are worrying about, how do I get it all back up and running and working if there is a problem, right? And this comes down to that the original purpose of this was to talk about how do you make data more declarative in the world of Kubernetes. What we're hearing is people want entire clusters, the entire application stack and everything related to it to be 100% declarative. So instead of saying, hey, I've got GitOps managing stuff in a cluster once the cluster's up, it's saying, I want to be able to one click, have a cluster come up from start to finish in a declarative way. This is taking it another level. It's saying, I don't just want the cluster to be able to come up. I need everything to be there and be available because I have stateful applications and stateful data running in Kubernetes, which is what people are more and more moving on to, especially as newer enterprises move on to using Kubernetes. Or probably a better way of saying that is enterprises that are just getting started and are, containerizing their existing applications, which a lot of them are stateful, are moving on to Kubernetes. They're going to be like, oh, cool, that's great. You can stamp out a cluster in as fast as it can be built. But how do I get my data from A to B? How do I know it's going to be there and be available and work? And I think this fits in with solving that problem in a very elegant way, right? The data can be in that to be state. The cluster doesn't even have to be there, right? Mm-hmm. It's already just replicated by Statehub to where I want to be, which means I'm not spending any money on anything, just the storage. And then in the event that I need to recover, I can use my preferred GitOps workflows or the tool Arlon that we've been working on at Platform9 that's about to be open sourced and say, hey, go. And it'll go and rebuild that entire cluster from the ground up, install everything. And then once that cluster comes up, those apps are going to say, hey, I've got access to this volume. It's been mounted through Statehub and it's there, and they're going to continue running. And there's been no manual intervention from an operations side. It's all been that design and architecture up front, and everything's been done through a declarative. So state really isn't going to be a problem here. Things will work because it's all running identically across every single place that it's been told to be running in.
Exactly.
So together we can create like a fully automated from zero, from scratch to a fully functioning environment like a single command. That's a very powerful automation, basically.
You don't have to reference storage anymore. You don't reference your PVs because they don't exist when you try to move your application from one place to another. They don't exist when you try to move your application from one availability zone to another, let alone a region or a cloud vendor. So instead of referencing storage volumes, a C drive, God help me, is always different on each machine. But here you can have an abstract, I don't know, slash DB for your application that it will always to your data. What we've created is what I like to call the global PVC, the global persistent volume claim, which references your data and not the physical storage on which it is located at a certain point in time.
Yeah.
Exactly. If we stop associating storage with data and start thinking of data of a Dropbox type of experience, that I don't know where Dropbox are holding my data. I just know that it's available when I need it. And that's the most important thing. Storage is a product, a physical product you buy from an infrastructure provider. Data is what your application needs. And given it this global persistent volume claim that allows the data to follow the application and give it the same agility as the application layer, is just a sort of like a game changer when it comes to how we look at data.
Yep. But unlike Dropbox, a thing here that we need to address when we talk about Statehub, the data is physically in the same regions as your Kubernetes clusters are, right? When you register
high performance for your application.
Yeah. When you register your clusters with Statehub, Statehub builds a private storage network for you that's available at your locations, wherever your clusters are.
Yeah, that's a good point.
Exactly. Okay, guys. Bart, do you have anything to add to the?
No, it's really nice because, like I said, we've been around for almost 2 years. And when I first got to talking to the folks at Statehub, seeing how they really got it, and that, because a lot of people are like, hey, I know Kubernetes. When you start getting into these things, a lot of times the people might get a little bit reserved or not so confident, and that they've just been told, you just do everything statelessly. This has been told from the very beginning. Then it's very comforting for me and energizing to hear Chris's comments about how we're getting to the point where organizations will be like, yeah, but what about my data? And what if I want to move it from here to there? And really approaching things with that stateful mentality. For me, it's really good to be here, having been in the community now for over 1.5 years, to see us getting to this point where we're really doubling down on these kind of conversations and seeing that they're being valued by customers.
Yeah, good point.
Yeah.
I think
I was going to say, I think one of the things that complicates it is, let's say I'm Chris, I want to learn Kubernetes. What do I do? I'm just going to go to AWS. I have access to that. I'm going to make an EKS cluster. That comes with, this is there, right? EKS is free, but all the resources underneath, that's what Amazon wants you using. And Google and Azure do the same thing. So people that are learning Kubernetes are like, so what's this thing? Helm, that's easy. What am I going to deploy? Maybe WordPress. I know what that is. It's not complicated. If I can make that work, I can make anything work. It uses stateful data. In this entire process, I've done nothing related to storage because the hyperscalers have said, hey, here, this is there. It's like magic. But then as soon as they start trying to get to the next level, they have to start thinking critically about it. It's complicated. Not only is it complicated, it's changed, right? CSI drivers are relatively new in the world of Kubernetes. So no wonder people are getting stuck or saying,
I can't imagine the poor people who deployed their stateful applications on Kubernetes using the in-tree storage and persistent volume drivers, and have to migrate all their data into CSIs. It's even redeploying like your existing application just because, I don't know, your Kubernetes cluster crashed or malfunctioned. I don't know, just redeploying everything with stateful applications it's really tough.
Yeah, especially if you forgot to change the reclaim policy from the just because you want to throw away your Kubernetes cluster and deploy another one.
Yeah.
Such an easy mistake to do.
There's a flip side to that. Let's say you did change it, you did it in development, and all of a sudden you've got clusters that are creating all these volumes and you're not paying attention.
Yeah.
Yeah.
And
then you've got a cost problem. So you can get burned on both sides.
Yeah.
Yeah, there's definitely a lot of ways that we hear from our customers of their stateful challenges, we'll call it, and the way that the main challenge that we see is that people don't want to deal with this. Like, it's not about, I don't have the time to learn, I don't have the necessary skill set or whatever. It's not even that. They just don't want to deal with it. It's 2022, and it's about time that the experience of stateful and stateless will start even up. So we can enjoy a singular workflow and support CI/CD acceleration and less vendor dependencies and all of those things that we forgot about them a little bit when we went to the public cloud.
Yeah, yeah. We like to call that democratizing the cloud.
Yeah,
Just making it equal.
Yes.
These are generic services. It's infrastructure. Thanks for setting it up. Let's just consume it. Let's not care which one of the people we're paying for it to. Let's make sure the costs are within our budget.
I've been waiting for this day where like the Uber of clouds since, I don't know, since I first heard of Kubernetes 5 years ago, I think.
yeah.
Yeah. And when you heard about it, it was just stateless, like they thought everyone.
Yeah, but I wasn't thinking about it as I'm thinking about it today as an abstraction layer above all the cloud providers. I didn't think it was even possible to become such a huge thing as an open source project, but they proved me wrong.
I call it a happy accident.
Yeah.
That's
Bob Ross. Yeah, that's good.
yeah. I don't know if anyone planned it, but it definitely happened.
The guys in Google that invented it didn't.
Go ahead and watch the Kubernetes documentary. So it's a good one.
Yeah, definitely.
So if people have questions and they want to start doing more, learning more, chatting, what's the best way for people to get going next? Bart, where should we go?
Everyone has a home in the Data on Kubernetes community. We're very active in terms of the content we're putting out. Also in terms of blogs, and we also have an open source project so that people can get hands-on experience working with it regardless of their experience. So yeah, that's definitely, I would say, I can speak for myself in my community in that sense, but I am very encouraged by, like I said, when we got started in July of 2020, it really felt like we were just the nerdy kind of outcasts that no one wanted to talk to. But by reaching out, interacting with more and more folks, and then also getting end users to come to the table, like it's one thing if it's someone who's just working on technology, but when they say, no, we're going to bring in a bank, or we're going to bring in one of the largest e-commerce providers in Europe, these things make people really start to take these things seriously. Because as we say in the United States, if it doesn't make dollars, it doesn't make sense. Technologies can be wonderful, but if people aren't willing to, if it's not adding business value, it's going to be tough that people are going to listen. So yeah, I would definitely. I also recommend check out the research report. It's not long. It's very intuitive. We use part of it today, but there's a lot of other stuff in there as well. We'll be repeating that this year, so it'll be really interesting to compare and contrast the findings that we got from the first round, with the second round that will start in September.
Yeah,
And that's just that's DoK community.
Absolutely.
you have the Platform9 fortnights if you want to learn a little bit more about Kubernetes, and you have our webinars that we are going to continue to run and post.
Yep. Statehub.io/start to create your Statehub account with 100 gigs of free multi-cloud, multi-region replicated storage. How do we get started with Platform9, Chris?
Platform9.com/sign up. It's pretty straightforward. It's free. Off you go.
And you
Got
can
some cool stuff coming out in a couple of weeks as well, so stay tuned.
Yeah, and we can start, you can start your Kubernetes journey basically for free with storage that is completely Kubernetes native and is ready to deploy cluster on whatever infrastructure you would like using the Platform9 Kubernetes as a service platform. I do recommend you do that. So I want to thank everyone that joined us from the DoK Foundation, from Platform9, Chris, always a pleasure, and Michael and Uli as well, and thank you for joining us. And if you have any questions or whatever, feel free to shoot us an email or go to our website statehub.io and sign up for a demo or send us a chat.